Alright, ladies and gentlemen, today we are going to talk about circumcenters. And a circumcenter is a location in a triangle where if you create a triangle in a circle, so the triangle is inscribed in the circle, that the perpendicular bisectors of the triangle sides will meet at a point called the circumcenter. And we're going to build that today. So the first thing that we're going to do is we are going to create our triangle inside a circle. So I provided the circle here, and I'm drawing the little lines because I want my triangle legs to just touch the circumference of this circle. So we're going to create the segment from B to A, then from A to C, and then from B to C. Okay, so now I have a triangle that has been inscribed, so put inside of a circle. Next, I've got to create those perpendicular bisectors. So remember, to create a perpendicular bisector, I'm going to set my fang or my compass a little bit over half or the midpoint of a section. So segment AB is 11 centimeters, so half of 11 is 5.5 centimeters. So I'm going to put my fang just a little bit above 5.5, just a little bit above 5.5, because I don't want my arcs to be too big. So I'm set it at a little over 5.5, and I'm going to create some arcs. So I can create my perpendicular bisector, which means I'm cutting this thing in half. This segment. So here's my perpendicular bisector. Remember, I am going from where they intersect. Now we want to draw that line into the triangle because I don't know where the circumcenter is going to be. We're going to label that midpoint because where it intersects is the midpoint of B to C. We're going to label that point D. And remember, these guys are congruent to each other. So segment BD is 5.5 centimeters, and segment DA is 5.5 centimeters. Alright, then we're going to do BC. I'm measuring BC. It's 11 centimeters as well, so I don't have to move my compass. That's nice. Make sure we're on the right fang, so slightly over 5.5. And I'm going to create my arcs. Alright. And then I'm going to create my perpendicular line here. This is my perpendicular bisector. Now we've got to make sure that we are intersecting our first line. Because remember, where these perpendicular bisectors meet in the triangle is our circumcenter. So the point that I bisected, segment BC, we're going to label that point E. And then remember, this was the same measurement, so B to E is 5.5 centimeters, and it is congruent to E to C, which is 5.5 centimeters. And then we're going to do the same thing for the final segment, segment AC. This guy measures 9 centimeters, so 9 divided by 2 is 4.5. I'm going to move it just a little bit above 4.5, and I'm going to create my final perpendicular bisector. So I'm going to create an arc, create another arc, and then draw my perpendicular bisector. Okay. So the point where I intersected segment A and C, I'm going to call that midpoint F. And then remember, segment AF is congruent to segment FC. And this guy was 4.5 centimeters. Both of them were 4.5 centimeters. Alright, so now I have my perpendicular bisector. So I'm going to write those off to the side. So I've got segment DK. Oh, before I can do that, I need K, right? K is my circumcenter. So this guy is going to be my circumcenter here, point K. So I got DK, segment DK is perpendicular to segment AB. That's this guy right here. DK is perpendicular to AB. Then I've got segment EK is perpendicular to segment BC. So that's this guy right here. EK is perpendicular. So, and then I've got FK is perpendicular to segment CA, which is this guy right here is perpendicular. So these guys are perpendicular bisectors. So I'm going to go ahead and color in this right angle here, so that I know that these guys are right angles, because they are perpendicular bisectors. So the thing you have to remember about a circumcenter is it is created through perpendicular bisectors. All right. So now I have my perpendicular bisectors. Now we can also create triangles. So I can create right triangles out of the triangle I have here, because every shape is made up of triangles. So we're going to create right triangles. And to do that, we're going to take the vertex of my triangles and we're going to draw a line from the vertex down to the circumcenter. So we're going to go from point A to point K, and then from point K to point C, and then from point K to point B. Now you can tell I have a bunch of triangles here, and they're all right triangles. Well, let's take a look at something. Let's take our compass and measure from K to A. Mine says about 6 centimeters. Well, let's measure from K to C. Oh, look, that guy's 6 centimeters. And then go ahead and measure from B to K. That is also 6 centimeters. So not only do I have perpendicular bisectors, but the lines that I create from the vertex to the circumcenter are all the same. So these lines are all congruent to each other. That's important. So a circumcenter has perpendicular bisectors, and the lines from the vertex, the triangle vertex, to the circumcenter are congruent. So this is very important. For a circumcenter, I have perpendicular bisectors, which means my side lengths are congruent here. And the line that goes from my vertex of my triangle to the circumcenter is also congruent. That's how I know how to solve a circumcenter. So now I can ask you about any length or angle in here. So using the Pythagorean theorem, so remember the Pythagorean theorem is if I have two legs of a right triangle and a hypotenuse, I can say a squared plus b squared equals c squared. So if I'm going to use, let's use this triangle right here. I've got, looks like just like this, with a right angle. This guy's 6 centimeters and this guy's 5.5. I can find that height by plugging it into this equation here. So A can be x, so I've got x squared plus my other side length, 5.5 squared, is equal to 6 squared. So then using math, because I want to get x by itself, I've got x squared is equal to 6 squared minus 5.5 squared. And then I have to take the square root, so I got the square root of 6 squared minus 5.5 squared. So that gives me x is equal to 2.4 centimeters. So this guy is 2.4 centimeters. Now I can do this with any of these triangles to find my perpendicular bisector lengths. Now if you also look at these triangles, you can probably tell that I have triangles that are congruent to each other. I've got 3 sets of congruent triangles here. So I'm going to use a highlighter to show you what these are. So this guy right here, this triangle, I got 5.5 and 6 is the same triangle as this guy here. And then I've got 6 and 6 and 5.5. These guys are the same. And then last but not least, these triangles are the same. Isn't that cool? There's a lot of patterns in this guy. So now what makes this nice because of these patterns, if I take my protractor and let's measure angle EB. So if I measure the measurement of angle EBK, EBK is roughly 23 degrees. This guy's roughly 23 degrees. So that means because these two triangles are congruent, this guy over here is 23 degrees. Now if I measure angle, there's supposed to be an angle sign there. If I measure angle KBD, I've got roughly 25 degrees. So because these two triangles are the same, this guy up here is also 25 degrees. And then if I measure my pink triangle here, the measurement of that guy is roughly 42 degrees. So the measurement of KCF is 42 degrees. And because these two triangles are congruent, this guy over here is 42 degrees as well. And then using the interior sum of a triangle, I can get these measurements up here, which I'm not going to. But as you can see, there's a lot of symmetry in the circumcenter of a triangle.